Okay, so to solve a quadratic equation that looks like this, you'll notice you have an x squared term and you have an x term which you cannot combine, which would normally make this difficult to solve. So we have to kind of go back a minute and think about something we call the zero product property, which says that if two numbers, let's call them a and b, multiply to equal 0, then one of those numbers had to be 0 to begin with, right? So if a times b is 0, either a equals 0 or b equals 0. So what we want to do is think of these quadratic expressions as the product of two terms. So for example, this is aside from this problem. Say I had something like x minus 3 times x plus 2 equals 0, right? Well, I've got two things that multiply to equal 0, so that means either x minus 3 had to have equaled 0, or x plus 2 has to equal 0. And then, of course, that's easy to solve. Add 3, x equals 3, or x equals negative 2. So if we can get a quadratic equation written like this, it's easy. Now, of course, usually we're given something in what we call standard form rather than factored form. So the big key is factoring, which is going from this form to this form. So let's think about this for a second. If I were to multiply this out, then I'd do, well, let's just write again, x minus 3 times x plus 2. To put that in standard form, you can remember your FOIL or your box or however you want to do it. X times x is x squared. On my outside, I have 2x. On the inside, I have negative 3x. And then I have a negative 6. So that's really x squared minus 1x, or minus x, minus 6. So to think about how do we go from here back to this factored form, we just think about where each of these numbers came from. The minus 6, notice, was when I multiplied those last two, the constant terms, in other words, negative 3 times 2. And this negative x in the middle, or you can think of it as negative 1x, came from adding up the 2 multiplied by this x and the negative 3 multiplied by this x. So it's basically these two numbers added together. So, moral of the story, if I have something like x squared minus 8x plus 15, to factor it out, I'm looking for, well, but this way, I know this x squared came from x times x, and then I'm looking for two numbers that multiplied to get this number on the end, so two things that multiply to 15, which is either 1 times 15 or 3 times 5. But I'm also looking for two numbers that when I added them together in the middle, gave me this middle number. So which of these adds up to 8? Well, negative 8 would be 3 and 5, of course, and in this case, to make it negative 8, I want to do negative 3 and negative 5. And now I factored it, and then I could go on to use the zero product property. So let's put that all together. Take a look at this problem. I have x squared plus 4x minus 11 equals 1. The first thing to keep in mind is that we're using the zero product property, so I have to make sure I get it equal to 0 first. So I'm going to subtract 1, and so I have x squared plus 4x minus 12 equals 0. And so now remember, we want to factor it out. And so that is the two numbers that multiply to negative 12 and add to 4, because I know that x squared came from just x times x. So multiplies negative 12 adds to 4. Of course, I have 1 times 12, 3 times 4, and you don't have to write all this out. 2 times 6. And the only combination that could add up to 4 would obviously be 2 and 6. And then I just double check. To get to a positive 4, I know I want my bigger number to be positive, so I want positive 6 minus 2 will give me 4. So negative 2 times 6 is negative 12, and negative 2 plus 6 is 4. Oops, I lost my... And that was equal to 0. So if this times this equals 0, then either x minus 2 equals 0, or x plus 6 equals 0. And so I have x equals 2, or x equals negative 6. And of course, if you don't want to write out all these steps, that's fine, but that's how we solve.